Okay, so this last type of calculation we need to look at has a look at excess and limiting reactants. So when we look at an equation, we're only interested in the reactants, therefore the left-hand side of the equation. So tell you what we'll do, let's cross out the products. All right, so they're gone. So what does this equation tell us about the reactants? Well, remember, we don't bother to write ones in chemistry, but it tells us that methane and oxygen react in a 1:2 ratio of moles. So let's have a look at the table in question 1. And I'm going to do the first two for you. So 1 and 2. You can have a go at the rest. So the first row of the table tells us we've got 1.0 moles of methane. I find it a really good idea to write them above the formula in the chemical equation, and that reminds me of the ratio. Now, if you've got 1 mole of methane, you need 2 moles of oxygen. If you have a look at this, we've actually got 2.5 moles. We've got too much, so therefore oxygen is the reactant in excess. So let's put a tick there. Okay, let's remove those for number 2. So in number 2, that tells us that we've got 0.5 of a mole of methane. If we've got 0.5 of a mole of methane, we need 1.0 moles of oxygen because it's in a 1:2 molar ratio. Now look at the table. We haven't got 1.0 moles of oxygen. We've only got 0.75. There's not enough oxygen. That's our limiting reactant. Therefore, the other one is in excess. So let's tick that. Jot down any questions you might have, but then have a go at the rest of them yourself. Okay, let's have a look at the next one. So it says if the question gives masses, you need to calculate the number of moles first. But firstly, let's focus on the equation, and it tells us that our reactants react in a 2:1 mole ratio. Like last time, let's forget the product. Now, what we've got to do is work out the number of moles of each reactant. Now remember, when we've got masses of a solid, or indeed masses of a gas, we do mass divided by mR. So for the first one, magnesium, 24 divided by 24. That's the AR, the relative atomic mass of magnesium, and that is 1 mole. Let's work out the number of moles of oxygen. So remember, for our gas, number of moles is mass divided by mR. So 14 divided by, of course, it's O2, so that's 32. And then we get 0.4375 moles. Let's use the ratio in the equation. If we've got 1 mole of magnesium, looking at that important 2:1 ratio, we need 0.5 moles exactly of oxygen. We've not got enough, have we? We've only got 0.4375 moles. So therefore, oxygen is our limiting reactant, and magnesium must therefore be our reactant that's in excess. Now the next calculation, number 3, gives us not much help at all. Remember, we only focus on the reactants, so let's write them down in their ratios. Now, what do we already know? Well, we know we've got 2.5 moles of hydrochloric acid. That's given for us. And we've got 40 grams of magnesium. Now, we're going to have to work out the number of moles of magnesium, and that is, of course, mass over mR. So 40 divided by 24. So let me put that on my calculator, and I get 1.66 recurring. So 1.66. Let's have a look at the equation. So, if I've got 2.5 moles of hydrochloric acid, HCl, that was given for me in the question. If I use the 2:1 ratio in the equation, I need, therefore, 1.25 moles of magnesium. Have I got 1.25 moles of magnesium? Well, I've got more than that. Therefore, magnesium is in excess, as it says for you in the question. Have a go at the rest of them.